So welcome everybody. On behalf of the Astrobiology Science Conference and ASU PlanetWorks, I'd like to welcome you to this public event, Managing Earth as a Planet. I'm Ariel Onbar. I'm a professor in the School of Earth and Space Exploration at ASU and also director of PlanetWorks. And I'm one of 800 astrobiologists who spent the past 4 days here thinking and learning about one of the most fantastic scientific quests that humanity is undertaking, the search for life beyond Earth. It's impossible to think about that topic. It's impossible to think about life on other worlds without also thinking about the future of this world. And that future is in our hands, in human hands, because we're entering a remarkable new epoch of Earth's evolution, an epoch that scientists are starting to call the Anthropocene. That's what we call this new epoch during which humanity is becoming one of the most powerful forces on the planet. And it's an era that's both remarkable and frightening, because we have to grapple with a very big question. Do we, as a species, have the wisdom to manage the future of this planet? So working with the Origins Project, we've assembled a fantastic panel to discuss this future. And so I'm pleased to turn the proceedings over to Lawrence Krauss, the director of the ASU Origins Project.
Thank you. Thank you, Ariel. Does this work? Is this working? Oh, good. I can hear myself. Good. Well, thank you for coming and finding this room, which is no small feat. We are pleased to have a wonderful panel here to discuss the official title, the long form title of this panel is Managing Earth as a Planet, How Astrobiology and Exploration Inform a Perspective of Planetary Stewardship. So we're going to talk about planetary stewardship in this particular era, which is Ariel mentioned as the Anthropocene. Now, the interesting thing is this meeting is astrobiology. One of the main parts of astrobiology is to look for life elsewhere in the universe and to find out whether there are habitable planets. And every week almost one hears about a new habitable planet. I was just talking about one or two on TV yesterday, actually, in our PBS station. And discoveries are made all the time of what are potentially habitable planets. And right now, habitable planets are often defined as water worlds, worlds that have liquid water. Now, the interesting thing is that's a gross definition, because we live in a habitable planet. But what's rather interesting and sad is that while we live in a habitable planet, rather quickly, large parts of the planet are becoming inhabitable, at least for life forms like ourselves. And that's a concern. And it's a concern because, indeed, as Ariel mentioned, we're entering an era where humans are having a global impact on the environment in a way that's never happened before, changing the environment and changing the climate of this planet, and in ways that at this point are inevitable. I'm sad to say. The climate change is happening. It's not something in the future. And the carbon that we put up in the carbon dioxide that we put up in the atmosphere is going to stay there for about 1,000 years unless we do something about it. And that means that they're going to have huge impacts on the planet, from obviously sea level rise and the acidification of oceans and more severe storms and droughts around the world, maybe in the Southwest as well. I want to start, by the way, on a low level, and I'm going to allow the panelists to be a little more optimistic. So I'm going to present the pessimistic view. And that means we have to consider ways, we either live with that and die with that, or we think about ways to manage the planet we live on in this new era where, I think my friend Jim Hansen always says, if you broke it, you fix it, it's yours. And we've broken it, and now it's up to us to own up to that problem. And that means trying to understand the processes that affect this planet. And one of the ways to think about that is to think about planets more generally, which is one of the reasons why it's useful to have this group here at this particular meeting. And also ways to model the future and ways to try and impact the future. And each of our panelists is going to talk in different ways about viewing the planet. And that means thinking in new terms, thinking about the cost of things that economists never thought of as costing things. Because if there are an infinite number of resources, you never have to really take into account the cost of resources. But we're well past that. We have to think of the cost of carbon. People talk about that a lot, but they don't talk about the cost of water, which is probably going to be equally severe. And one of the reasons I want to sort of end my little introduction with water, which in one way is because we live in a water planet, is that climate change and the availability of fresh water, not just ocean sea level rise, are intimately related. And the Origins Project is actually, after co-sponsoring this panel, over the next weekend, is having a weekend on climate change awareness. We're having a scientific conference on the coming water wars, where we're going to bring people in to talk about everything from locally the availability of fresh water to globally that problem, and issues of available fresh water and sea level rise and climate change more generally. And as we also like to do, we also have several public events associated with that. And this is, in some senses, the opening public event. The next 2 nights in Gamage Auditorium, we're going to show some films related to this and have the directors involved. And tomorrow night, we're going to have Fisher Stevens, who along with Leo DiCaprio created a movie called Before the Flood. And at Gamage Auditorium, we're going to screen the movie, and then Fisher Stevens will be here to talk about it with me afterwards. Leo DiCaprio was actually going to be with us, but he has a climate change march in Washington the next day. And then Saturday night, and you can get tickets for both nights, we're going to have a different view, a fictional view of an eco-drama of a possible tragic set of events that relate to water. And the director is the famous director, Werner Herzog. The movie's called Salt and Fire. And Werner Herzog will be here with us on Saturday night. And we're also going to, as well as talking about that fictional tragedy or crisis, we're going to have Jeffrey Sachs, one of the world's most famous economists, who has thought a lot about climate change and advised the UN, among other things. And he'll be there. So Werner, Jeffrey, and I will have a dialogue after the movie. So I encourage you to consider there are tickets available still for both at Gamage Auditorium at ASU. So having made that, announcement, let me just talk to you about one aspect of water and the Anthropocene before I turn to our panelists, just to start, as I say, low. There's a wonderful book which one of my colleagues gave to me called Water, The Epic Struggle for Wealth, Power, and something else, which I can't read. And one of the first things in here is that water is quickly overtaking oil as the world's scarcest critical natural resource. Today, at the beginning of the 21st century, there's hardly an accessible freshwater source or strategically placed waterway on an economically advanced part of the planet that has not been radically and often monumentally engineered by man's prodigious industrial power. As world population continues to be propelled towards 9 billion by 2050, with so many third world inhabitants starting to move up towards consumption and waste generation levels of the 1/5 living in industrialized nations now, demand for more fresh water is continuing to soar. Yet, as written here, but we'll see whether our panelists can discuss that as well as other things, yet no new innovative breakthrough capable of expanding usable water supply on a large enough scale to meet the demand is anywhere evident on the horizon. Over the past 2 centuries, freshwater usage has grown 2 times faster than population. Humans are affecting every part of this planet, and we need to understand that and deal with it. And that's why, fortune favors the prepared mind, and that's why we've invited 4 prepared minds to talk today. And the first panelist I want to introduce is an old friend of mine, John Grunsfeld, who's famous for being an astronaut, among other things. One of my favorite astronauts of the whole crew, because he's an astronaut scientist and truly excels in both of those things. Not only has John been on 5 different trips to the space shuttle, to the International Space Station with the space shuttle, he has fixed the Hubble Space Telescope 3 times, and he is a scientist. He graduated from MIT in physics, and then at the University of Chicago did his PhD in physics, then went to Caltech where he's a research professor, and then decided to become an astronaut and radically affect the future of science by helping repair the Hubble Space Telescope. And then he, after ending that period, he went and actually was deputy director of the Hubble Space Telescope Institute, and then decided he missed NASA too much. And he went back to be the associate administrator, basically the head of science at NASA. And he's been spearheading science at NASA during that time, from which he's just retired and is now going back to be and astrobiologist. John.
Thank you very much. Alrighty, so astronauts are not really well known for their humanity, and certainly not scientists. You know, we tend to like our science and to avoid all human contact. But the story that Lawrence just laid out is a human story. It's about planet Earth, but it's about humans on planet Earth and our interaction with the planet. So I thought I would give you the human perspective from orbit, you know, not the Hubble Space Telescope repair stuff. And I don't know how well you can see, but this is actually a picture of me working in a vacuum, which really made total sense to me because all my life people have been saying, what, you work in a vacuum? And in fact, yes, I do. But what's solid about this picture is I am out in a vacuum in my spacesuit, which is sort of like a mini Earth. It has its own environmental control system. But reflected in my visor is a reflection of planet Earth. And truly, the view from space is the best place to look at the Earth, and something that I enjoy greatly. And you can see on my face is a huge grin. And that grin I have almost all the time when I'm in space. Now, most of what you're going to see here is the images that I took on a mission in 2009 to the Hubble Space Telescope through the space shuttle windows. And so they're not always super clear because somebody will have stuck their face up against the window and gotten, you know, some grease on it. But we really have this fabulous view with the space shuttle and now the space station. The images were taken with a standard, you know, Nikon digital camera, sometimes a wide-angle lens, sometimes a long lens. So, you know, this is the kind of views. There's something in the way in this picture of the Earth. That's the Hubble Space Telescope after we deployed it. And, you know, the views of the Earth that you've heard about from astronauts, you know, maybe you've heard a lot of flowery talk about, you know, how the Earth looks perfect and there's no borders and, you know, you can't see the strife of humans on Earth from space. None of that's true. But that doesn't change the beauty of the Earth. So since this is an astrobiology conference, what I thought I would do is take the view of, you know, what if some alien species were coming into our solar system and, you know, wanted to look at the Earth. Now, for the astrobiologists in the audience, I do want to just say, you know, that one of the things that strikes me the most, and for all of you, in fact, is that the Earth's atmosphere really is tremendously thin and fragile. And this is a sunrise over the Earth's limb, and that thin line is 100 kilometers or so of our atmosphere, of which our habitable part of the atmosphere is only a very thin one. And also, when we do transit spectroscopy, that's the amount of atmosphere we're able to look through, which is, to me, pretty incredible. So here we are on our voyage. We're approaching the Earth, and this is actually an image that was taken with the Lunar Reconnaissance Orbiter camera, centered here at Arizona State University at CC by Mark Robinson and his team and students. It's a satellite orbiting the moon, and it looked back at planet Earth. And from this distance, in fact, you can see the Earth as kind of this pristine, you know, planet that, you know, is unaffected by the goings-on. If you watched for a while, you would see, you know, Africa going through its seasons and, you know, lots of storms. But as we get closer, we immediately start to see, there's something funny going on there. This is a picture of the big island of Hawaii as we flew over. And if you look in the upper right of that photo and also in the sort of center right, you can see contrails. You know, nature doesn't usually make these long, straight things. And those are, of course, airplanes going in and out of Kona and to Hilo, carrying lots of tourists and a few astronomers. If you look closely with that long lens, on the summit of Mauna Kea, those little white dots are the observatories. And you can see the Keck observatories and the Infrared Telescope Facility and the Subaru Telescope and little teeny roads. If you fly over Kennedy Space Center, now you find out that not only are there humans doing industrial things, they have launch pads and runways and bridges. And, you know, this is what you see when you look at Florida as you fly over. It's pretty clear there's something going on there. Now, whether you would assume it's life or some kind of, you know, robot automatons, you know, you might not know. Even if you look at the large scales. What you see there is this is obviously the Middle East. On the left, you can see the Great Nile Delta and the Nile River. To the left, actually, is Lake Nasser, which was only created in about 1990, and they've been diverting the Nile. And so I've watched that grow from a puddle to this huge lake that now has millions and millions of people living around it, and is affecting what goes on in the delta as well. But if you look to the right, you can see there's sort of it looks like a darker patch, but off to the right is Israel. And they do have large-scale desalinization, and so compared to their neighbors, they have a very vibrant agriculture that's not shared by anyone else. And that highlights them like a Rand McNally map that you can see from space, that there are borders, and that those borders are different socioeconomic environments. Flying a little bit to the east over Iran, out in the desert where nothing grows, there's little dots. And if this were a talk earlier in the week, we'd be talking about membranes surrounding, some kind of protoplasmic, organic molecule. This is center point irrigation. They've dug down and they're pumping out water from deep below the desert to do agriculture in a desert that, really shouldn't be growing plants. But it's to feed people. And what you see is that they're successful for a few decades, and then they've pumped out the aquifers, and then they dry up and they move a little bit. And so this is an easy thing to see from space. If you're a very rich country, you can expand your land use. This is in Dubai, and the sort of gray area in the middle is the city, millions of people, and they've decided to make huge palm tree islands out of sand. So you see those two palm trees surrounded by some kind of a dike, and they're building houses there. And you can also see more to the right, planet Earth. They're building continents and a horizon out of sand, which is really hard to maintain because the tides keep trying to take the sand out. What will the aliens think of that? There's a lot of talk about sun glint off of exoplanets, so I thought I'd put a sun glint picture in. This is the sun reflecting at just the right angle, so these shrimp farming fields are very bright along the coast of South America, and you can see some rivers going out, and it allows you to see the patterns of wind on the water, so you can learn a lot. But these are definitely geometric structures that are not natural. And then if you go a little further south in Argentina, this used to be grasslands and forests, and it's now been carved up into all those little pieces, and you see this massive fire. And that's one of the characteristics now that you see all over planet Earth are massive fires as they slash and burn forests. And so this is also in South America, clearing rainforests for cattle to graze. Incredibly inefficient, but that's what's going on. And when I first flew in 1995, there were large tracts of untouched Amazon basin rainforest, especially here on a tributary of the Orinoco River. And that was 1995. By 2009, you just about can't find someplace on planet Earth that doesn't look like this, almost like it has some kind of a disease. But these are people and companies who want to farm. They want to make a living. And again, it's what Lawrence said, people are modifying the Earth. And if you really want to know that there's life on Earth, just look at the night side. This is actually from the International Space Station. These are city lights, and it traces out the population. This is the central U.S. You'll see Lake Michigan coming up and Chicago, where I was born, and the dull glow of the atmosphere. And so there's no question when those alien spacecraft are on the backside, people are converting coal and natural gas and other things into light. So for me, I come back and land on planet Earth. What will the aliens do if they're not here already? Maybe they'll say, oh, no intelligent life on Earth, we're going to go elsewhere. But it's very clear from space that we are modifying everywhere on the surface of the Earth. The big surprise to me is that in flying, something like 58 days in space, looking at the Earth, I never saw a place that I couldn't view out the window. I couldn't pretty quickly find someplace, even the open oceans, a ship wake with a smokestack where there wasn't evidence of humans on planet Earth. And so to try and be optimistic a little bit, we now know that we can modify the atmosphere of a planet. We know we can modify the surface land of a planet. Now the question is, can we do it in an intelligent way, that doesn't make it uninhabitable and keeps us as a habitable planet? So I'll turn it over back to you, Lawrence.
Thanks, John. Thank you. Thanks, John. You always have the best pictures, and it's always I could just watch it for an hour. So thank you
Well, I've
for
got
the
a few more
global.
slides.
Yeah, you got more. Well, maybe we'll show more later. for that global perspective. Now we'll move to, we're going to start globally in a number of ways, globally in space and then globally in time. And I want to ask the next panelist, David Grinspoon, to talk. He's going to talk about the challenge of now, how to be a self-aware geological force. And David actually did his PhD at the University of Arizona, which we forgive him for, and in planetary science, and then was in Colorado when he was actually the curator of planetary science at the museum there, and then was the inaugural chair in astrobiology at the Library of Congress, and is now at the Planetary Science Institute. So, David.
Thank you very much, and thank you all for coming out this evening. As mentioned, I'm an astrobiologist. I mostly work in offices, so I don't have pictures of what I do and where I work that are anywhere near as cool as John's. So
no one does.
Yeah, exactly. So I'm not going to try to follow that with any visuals. So I'm just going to sit here and talk for a few minutes and share a few thoughts with you. What I do for my research is I model climate change on other planets and try to understand the possible locations for life in the universe. But I've spent a lot of time over the last few years studying and writing about the human presence on Earth from the viewpoint of astrobiology, and asking the question, given all the radical changes and catastrophes and transformations that the Earth has been through, what is really different about these changes that are happening now? And I think that plausibly the answer is, or one way to frame the answer is that we're seeing and manifesting the advent of self-aware geological change. A geological force that is coming to realize that it is a geological force. That's something new on this planet, realizing that we are a geological force. So it certainly is clear, as John was saying, that our planet is going through some kind of radical transformation now. Let's go back to this view of these aliens that John was talking about who are zooming in on Earth. But for a second, rather than zooming in space, let's zoom over time. Imagine you were a very patient alien with a different kind of time sense. So you were watching the Earth over billions of years and noticing its changes. What would you see? Well, you would have seen a lot happen, a lot of changes on the planet. Gone through different phases. You would have seen the continents drifting around through plate tectonics and continental drift, coalescing into supercontinents and breaking apart again. You would have seen climate changing, ice ages, hothouse ages, the polar caps growing and shrinking over the ages. A lot of changes. But then, to this patient, attentive, observant alien, very recently, you would notice something striking that you hadn't noticed over all these billions of years. A whole series of brand new things happening. Most noticeably, probably, the night side suddenly lights up, starting in a few dots in some coastal areas and then spreading in webs and then filling much of the nighttime continents. At the same time, all these other changes start happening. Changes in the composition of the atmosphere and the ocean, changes in patterns of the land surface, strange new geometries, squares and circles, and even the hydrological cycle of the planet, as Lawrence mentioned, really suddenly being altered. And then these linear clouds start streaking through the skies. And then very recently, in the last 60 years, which is a blink in the eye of the planet, little bits of the planet start launching into space, which is a really strange new thing. What a strange way for a planet to behave. Everything 4 billion years ago fell from space, and now all of a sudden some tiny little bits of it are launching back into space, circling around the planet, visiting the neighbors, sending radio signals back. So it's clear to you, the attentive, patient alien, that something radical and new is happening on this planet. What's going on? So we have a species that is both changing the planet and also studying the planet, trying to understand how it works and trying to understand our own role within it. But when we study the long history of Earth, one thing we quickly learn is that we are not the first species to come along and radically change the planet. That has happened before, that biology has changed Earth. For instance, 2.5 billion years ago, these little bacteria, the cyanobacteria, discovered a new energy source and realized that they could exploit it like crazy, and in the process polluted the entire atmosphere and caused a climate catastrophe. Sound familiar? But the cyanobacteria did that when they discovered solar energy, photosynthesis, and they polluted the atmosphere with oxygen, which at that time was a poison, and caused a horrible climate change. So we're not the first to do some of these things. What is really different about what is happening to the planet now? It's not new for biological processes to radically change the planet, but it is new for cognitive processes to change the planet. Mental processes enabled with technology, the ability to manipulate the environment, feeding back and causing global change. That's something brand new. Earth gave rise to biology, which somehow gave rise to these mental processes, which are now feeding back and changing the planet. A planet with brains? Fancy that. Not only brains, but limbs with which to manipulate and build tools. We're just beginning to come to grips with this strange new development, like an infant staring at its hands. We're becoming aware of our powers, but we haven't yet gained control over them. So how can we change that? Maybe by understanding more fully what's going on here. This cognitive influence on the planet, I think there's two categories that we can break that into, two ways this can unfold. Two kinds of cognitively driven planetary change. Inadvertent changes and intentional changes. And I think we have examples of both. The obvious inadvertent example is that we decided fossil fuels would be a great source of energy. They were, but without realizing it, we started changing the atmosphere, putting carbon dioxide emissions and causing what we're now realizing is a climate crisis. Completely unintentional when we started, an unintended consequence. Another example of an unintended consequence is the ozone hole, which you've heard about. In the 1970s, we realized that this very crucial life support system of our planet, the ozone layer up in the stratosphere, was being affected by these chemicals, these CFCs, chlorofluorocarbons, which we thought were perfectly safe and non-toxic, because they are down here where we live in the troposphere, but when they drift up into the stratosphere, they start interacting under the influence of ultraviolet light with the oxygen compounds and destroying the ozone. This was a real crisis, but we responded to this crisis in an interesting way. It definitely started off as an inadvertent, accidental change, but then something interesting happened. There were global discussions, arguments at first about this. The scientists raised the alarm. There was denial. People didn't want to deal with it, but ultimately it became very clear that this was the truth. This was happening, and the truth won out in this case. There were global agreements made. The Montreal Protocol was the key one, and we changed our behavior. The companies phased out those chemicals, phased in new chemicals. So that's a genuine example of an intentional global change in response to a problem. It's a proof of concept. It shows that we're capable of another way of responding to global problems. It doesn't mean that it's inevitable or easy, but it shows it's possible. So one way of looking at the challenge of now is that we have to shift our global influence more and more to the intentional side of things and away from the accidental, inadvertent changes. We have become planet changers. And I don't believe that we have the choice anymore to not be planet changers. So our challenge is to learn how to do it well, learn how to gracefully integrate our activities with the great natural cycles of the world, and learn to be a constructive rather than a destructive force. When we study the deep history of our species, we learn that we've responded to existential threats before many times by reinventing ourselves and redefining our relationship with nature in response to climate threats. This has happened before. Now we need to do this again. And after we get over our current climate vandalism and destruction of species, we will have many opportunities to play a constructive role on the planet. After we stop threatening a mass extinction, we can prevent the next mass extinction. We can stop that next dangerous asteroid that is heading our way. And ultimately, we can prevent the next ice age and other dangerous climate changes, which on a long enough timescale will happen, with the planet left to its own devices. I think we're just getting started on this planet. We are facing some huge challenges in the 21st century, but remember, there will be a 22nd and a 23rd century. We will soon have a stabilized global population, and we'll soon be off of fossil fuels. The transition is painfully slow right now, but it is also inevitable. And I think soon we'll be in the process of repairing the damage that we're doing now, and that in the long run we can save many more species than we're currently threatening. We've got a lot to learn about the planet and about ourselves. But eventually, we may be the best thing that ever happened to planet Earth. Thank you.
Thank you. Well, I told you we'd get more optimistic, although I hope to bring us back at some point. Well, you can't help but notice that we segregated the panel.
Right.
And we didn't do it intentionally, but I wanted to go from this side, which is sort of the, I'd call the vague side, to this side, which with the can-do side. And I want to introduce next Jane Long, who's going to talk about geoengineering. And Jane is an engineer and who did her PhD at Berkeley in civil engineering and geotechnical engineering, which I didn't know at the time was a field in hydrology, and has moved primarily around at Lawrence Berkeley Lab, and then was dean at University of Nevada at Reno, and then went back to Lawrence Livermore National Laboratory, where she worked on energy and the environment, and now has retired from that so that she can do science. And so she'll talk about geoengineering.
Well, I just thought I forgot my hat. Is the real problem. Thanks.
Award for you.
So geotechnical engineering actually used to mean, or geoengineering used to have the meaning of engineers who dealt with things at the surface of the earth, so foundations and dams and reservoir engineering and whatnot. But in the last decade or so, people have begun to use that term to mean actually engineering or modifying, because the concept of strict engineering of the climate is seems to be elusive, but intervening in some way in the climate. And of course, as you've been hearing a bit about our problems on the Earth, I'd just like to give you a little bit more detailed context so that you understand some of the motivation a little bit. So Lawrence mentioned the persistence of carbon dioxide in the atmosphere for 1,000 years. How many people in the audience really understand that when we emit carbon dioxide into the atmosphere, that we've bought that carbon dioxide, it's going to be there for 1,000 years? How many people really got that? This is a really good audience, I have to tell you. Usually if I ask for that, I get about 3 hands, even at graduate students at MIT. This is probably the most important fact about climate change that is difficult for people to difficult for the public to grasp. This isn't like the pollution problems that we've had other places, where if you put contamination into a river and then you stop doing it, the river gets cleaned up and problem solved, we're done, you know. But this isn't like that. Until we stop emitting, the problem's just going to get worse. And so we have to go to zero, really, or relatively close to zero, to stop the climate change forcing from increasing. We emit now about 40 gigatons of carbon dioxide a year, and that 40 gigatons is going into the ocean, about half of it, and the other half staying in the atmosphere. Even if we eliminated the extra carbon dioxide in the atmosphere instantaneously, all the stuff we put in the ocean would come back out, or half of it would come back out. So we have a really difficult time bringing that atmospheric concentration back to a pre-industrial area, range. And if we, for example, needed to try to do that, if we look at the IPCC, the International Panel on Climate Change, model results of what is going to happen to climate for various mitigation scenarios, if we followed the Paris agreements to say about 2030, And then at that point, we started taking carbon dioxide out of the atmosphere. We would have to take out about 10 gigatons a year. So we'd have to go to 0 and then take out half as much as we've been putting in, more or less, every year in order, sorry, not quite half, sorry, about a quarter of what we've been putting in every year in order to have a 50% chance of staying below 2 degrees. So it's really a huge lift that we face in correcting this huge perturbation that we've made to our atmosphere. And that means that it's very likely that we're going to be experiencing some pretty major effects, some large temperature changes and climate weirding, if you like, of what we see. So people have begun to think about what could you do about it. Human ingenuity is pretty amazing, and this is a field where only a few people have started to think about it. It's very, very important, I think, now for more people to think about how we might deal with this major perturbation so that we have a better chance for survival and that our children have a better chance, and in my case, I'm happy to say my grandchildren. But the two kinds of things that people have thought about doing so far, predominantly, are one is to mimic volcanic eruptions, which we know put sulfur dioxide into the stratosphere and have been shown to cool the Earth for several degrees for a year or so after the eruption. So we know that if we could inject particles that would reflect radiation back into space, that we could change the radiation balance of the Earth and cool the planet. And that has no effect on things like ocean acidification, because that CO2 is still in the atmosphere. So what it's doing is it's taking some unknown or risky situation caused by our carbon dioxide emissions and adding onto that a perturbation that is different than removing the carbon dioxide. It's changing the radiation balance. So we would enter kind of an unknown state. Model results show that it would improve climate pretty much everywhere, but our instinct tells us something might go wrong. And usually when I'm giving a talk about this, the microphone goes wrong or the temperature's too hot, or, and things like that. And it's pretty clear that we have a very hard time controlling all unintended consequences of this. So it really is going to be a very difficult decision to do something like this. And what we know, though, if you think about it, is we're not making a decision, or we would not be making a decision to reflect radiation in a situation that we're in right now, where it isn't this situation, it isn't this climate that we're experiencing now that we want to change. It's going to be a risk decision, the risk of doing nothing versus the risk of trying to change the radiation balance. And that has a very different flavor to it, and it is going to be a very new ground for people to try to understand that risk type decision. We also know that once we do this, if we ever stopped, that the temperature would go back to the path it was on before we started reflecting radiation and make a very sudden increase in temperature. So we know that it's not something we want to do all the time, forever and ever. We don't want to have to commit to that. And therefore, the thing that we really need to think about is trying to figure out how to get that carbon dioxide out of the atmosphere as quickly as we can and put it somewhere. Those techniques are called carbon dioxide removal techniques, and they are painfully slow, very expensive, and will be very, very difficult. So the idea that we would use a solar radiation management type technology for some period of time while we got our act together to figure out how to bring the atmosphere back to a safer situation is one that people have only begun to think about. The strategic use of these technologies to manage our climate is something that needs a lot more work and a lot more research. And this kind of research needs to be done in a way that isn't the way academia is currently configured to do research, for example, or even national labs anymore. This needs to be a kind of research program which is systematic research, probably much more akin to the kinds of things that were done at NASA, for example, in programmatic research, where we think about what the whole system issue is and assign people to investigate the components of that system and how they interact. This is not curiosity-driven research. This is going to have to be much more like engineering research. And that hasn't happened yet either. So I think these challenges to bring about what David has so eloquently described, we do have a few babies looking at their hands and trying to figure out what they're doing with it, but nowhere near enough people have looked at this. And I think we need to engage people in how, one of the things that I just want to say one other thing about this and I'll stop. You know, we have in the climate community a sense that we can't tell people how bad this problem is because they'll lose hope and they won't do anything. I think that we've done exactly the opposite. I think we have papered over how bad this is so people don't do anything because they don't think they need to. And that is something I think we really need to start to be more honest and straightforward about how the magnitude of the problem we're facing, as well as the magnitude of human ingenuity to do something about it. Thanks.
Thank you, Jane. Thank you, Jane. I next want to turn to my colleague at ASU, Hilary Hartnett, who's in the School of Earth and Space Exploration, which is the departments I'm in, as well as the School of Molecular Sciences, which in other places they call chemistry. She's an oceanographer, and which is an example of the kind of transdisciplinary approach that is done at ASU, one of its great strengths. And she did her PhD at University of Washington, and then was at Rutgers, and then came to ASU. And she's a biogeochemist, which is an interesting area. And she says basically what that means is that she is interested in carbon and water, and wherever you find them, she's interested in something. And she's going to talk about the role of universities in training planetary managers.
Thank you, Lawrence. And like John, I do have a few slides. I'm really happy to be going last because my fellow panelists have set me up beautifully for this. So what I'm going to describe to you is a new initiative at Arizona State where we wish to achieve nothing less than a thriving Anthropocene. We want to train the next generation of planetary stewards or managers. And this program is called PlanetWorks. I'm the co-director of PlanetWorks. Ariel, who introduced us this evening, is actually the other co-director of PlanetWorks. And PlanetWorks is an initiative. We think of ourselves as a confederation of scholars and centers and academic units, currently at ASU, but soon to be beyond our university. And our goal is to reinvent our relationship with planet Earth as we enter the Anthropocene. And to do that, we take a systems approach. We need to understand the past, present, and future of our Earth. There's a geosciences component to that. We recognize and begin from the premise that humanity is an integral part of the Earth system. You can't think about the Earth anymore without thinking about how humans interact with the planet, whether that's things we build at the surface like we saw in John's pictures, or whether that's how we change our atmosphere or think about changing our atmosphere again. The Anthropocene is not, it's not a problem, it's not a thing that we can undo. It's an irreversible evolutionary transition in our world, right? We have entered the Anthropocene. It is up to us to decide what that Anthropocene is going to look like. And the last sort of focus that we take in PlanetWorks is this idea that Earth is an intelligently managed design space. We have this ingenuity that Jane talked about. We can make conscious decisions about what we want our planet to look like. So we catalyze research programs. We have a strong element of education in what we do. We are interested in policy and advocacy, and those are words that are kind of unusual coming from a research scientist. But the PlanetWorks team is really sure that we have to be part of this process. We can't just sit back and study it and write papers about it. We have to then also put it out there, help people to think about it, build the conversation about what the Anthropocene can be like. So how do we do all this? This is a pretty grand idea, right? So we have a sort of 4 aspects of what we think about. One of them is what we call our Earth Intervention Collaboratory. It's a research and development concept where we work in teams of scientists and engineers and also social scientists and people who study law to develop ideas about how could we intervene in the Earth's climate system right now. And I'm going to talk about that again. Another element of what we're thinking about is something we call the Stewardship Studio, a place, literally, where people can come to learn how to think in this system's way, to help build ideas and think about scenarios for what planetary stewardship could look like. We have a strong education component, which currently is local education at Arizona State, but which we envision could be mass education, taking advantage of technology, online capabilities, to take this message very, very wide. And ultimately, all of these pieces link to better integrated models of how the Earth system has evolved and will evolve. And so you can see that this is a very much I'll call it a mission-driven kind of approach. We know what we want. We want a thriving Anthropocene. There's basic research that goes with this. There's applied research that goes with this. There's learning how to talk about this. So now I'm going to switch gears and I'm going to give you an example that mostly falls into the idea of the Earth Intervention Collaboratory, but I'm going to put it into an educational spin because it really did evolve out of a class. So this is an image of the Arctic, and here's Greenland, North America, the Russian far north, and the white that you see is the sea ice coverage in September of 2012. This is measured with a satellite that uses microwave radiation. And I don't know how well you can see it, but there's a black line kind of here. That black line is the average summertime September ice extent for the period of 1979 to 2000, so the latter part of the 20th century. And the key thing is that white that you see for September 2012, there's much less ice than there ever has been in the past. And 2012 was a particularly bad year, but it turns out 2016 is a pretty bad year too, and 2017 is shaping up to be about the same. We've lost a tremendous amount of summertime ice in the Arctic. And this ice is important because it's white, right? It's reflective, and this gets to this idea of the radiative budget of the planet. Our climate is carefully balanced between how much light comes in, how much light is reflected back to space due to white things like the Arctic sea ice, and some of that energy which is absorbed by the planet and re-radiated and then absorbed again by the greenhouse gases. That's a delicate balance. If we lose ice in the Arctic, the seawater that's revealed, it's not reflective, it's black. And so that's a fundamental change to the way the Earth absorbs energy. So my colleague Steve Desch, who was also the chair of the Astrobiology conference, came back from a conference a few years ago, and he was all head up about this problem of climate change and sea ice, and fundamentally kind of stomped around wanting to know why nobody was doing anything about this. Is that fair? Yeah. So, being academics, we decided to teach a class, basically, to talk about this idea. And so we had a seminar class. It had graduate students, it had undergraduates, it had a couple of faculty, and we put together some good minds to think about what can we do about ice in the Arctic. And it manifested itself last year in a paper in a journal called Earth's Future, which is published by the American Geophysical Union, called Arctic Ice Management. We've basically put together an idea for an actual engineering solution that you could apply that will help rebuild ice in the Arctic in the winter. So this data, the key thing to note is this red line, which is summertime ice. It's been decreasing steadily since the 1980s. And there are predictions that summertime sea ice could be gone by 2030. 2030. That's not that far away. We can all think about what 2030 might be like. It's harder to think about 2100. And we're losing sea ice because the temperatures are warmer. So the basic premise behind ice management is that, can we take advantage of the fact that it's still cold in the Arctic in the winter? Can we enhance ice formation? It turns out ice freezes at the bottom of the sea ice, and then the heat of fusion has to conduct through the ice, and that limits how thick the ice can grow. Essentially, it insulates itself. If you could pump seawater, and here's a very artist's rendition of our idea, if you could pump seawater from below the ice up to the top of the ice, and we have a wind-powered pump, then you freeze ice at the minus 40 degrees of the Arctic winter temperature. And our calculations suggest that we can freeze about almost another extra meter of ice each winter if we have enough of these pumps. This is a very different approach to thinking about geoengineering. This isn't in any of the National Academy reports on geoengineering techniques. We've gotten lots of press from all over the place about this, and most people are like, no one's ever talked about this before. So this is a PlanetWorks pilot project, if you will, which is a very novel way to think about an engineering solution for Earth's climate. Now, it is an albedo modification. It's a Band-Aid that will help keep the radiative transfer budget from changing. It's not going to fix the CO2 problem, but it might prevent warming. Because when the ice melts, you get a positive feedback that warms the planet. So we're in the process of thinking about how do we do this? What do we do next? We did some calculations and we wrote a paper. The next steps are myriad. We need to test a prototype. We need to build a prototype. We need to train students to think about this, both the engineering side of it and the political and social and ethical consequences of such an activity. We need to have better models of what impact this will have on the ice, and these all fit into the different aspects of what PlanetWorks is about. But I think the really important thing that we need to do is we need to widen the dialogue about what geoengineering can look like and how we can begin to think differently about solutions to, in this case, a climate problem, the loss of Arctic sea ice. So with that,
Okay, thank you. See, thank you, Hilary. Well, we moved from the pessimistic to the optimistic to the can-do, and I want to cover all those topics a little bit and have a little discussion here, and then we'll open it up to all of you to be able to ask questions. And in this case, you get to ask them in real time, unlike many of our Origins events, and we have microphones set up for you. But I want to ask each of the panelists a question or a question or two, based on what they said, and that may lead to a discussion or not. I want to just make sure we give you all time. But John, I want to start with you. You talked about the changes you've seen. Over what period were you flying? From what was the range of periods from the time you first looked down at the Earth to the time you last did?
So my first flight was in 1995. So that's quite a long ways from the very first, Gemini, Apollo astronauts. But 1995. I then flew in 1997, 1999, 2002. So I had a pretty good gig going.
Yeah.
And then we lost Columbia. So there was then a long span. 2009 was my last flight.
Okay, so 14 years basically over.
Yep.
And you did see changes. What was and you talked about them, but I'm wondering, what was the most jarring change, if you can think about the thing that really surprised you? Probably a lot of it was expected. Was there anything that you saw from space that you hadn't expected and sort of made you step back and think about the situation that we're in right now? Anything?
Well, first of all, most of the time I was concerned about the Hubble Space Telescope.
You were
that was
looking
kind of my
up.
prime job. And, maybe not in the way you think. It's don't break the Hubble.
Yeah.
Because then I shouldn't come back.
Yeah.
Or at least I'd be in exile in Bolivia. But there is one thing that I definitely noticed. I mean, there were the structural changes that you've heard, and I mentioned like NASA, and there were lots of things: cities growing, new roads. those islands in the Red Sea. But the one thing I did notice is that, and it's somewhat seasonal, but I flew enough different times, the atmosphere has gotten a lot more dusty. On my first flight, it looked pretty clear. And by 2009, there really were no places that didn't have kind of a haze. And looking through the atmosphere, the sunsets were a little more dynamic, and you could actually see that in the scattered light. But, and that's something that's been described by, a lot of astronauts who have flown over different time periods. And talking to those Apollo astronauts, they talked about a really clear atmosphere and being able to see a lot further than we could.
And that's dust. That's not the kind of Los Angeles haze you see. That's literally dust due to drought or
So it's a combination of factors. A lot of it is human-made aerosols, particularly from coal-powered electricity plants. And some of it is dust lofted, for instance, from the Sahara and sub-Saharan Africa due to drought.
Okay, the last thing I want to ask you, and you hit on it, you talked about aerosols from coal-fired power plants, which, as you know, is something that the current administration is keen to keep pushing and make worse in their effort to try and make sure that the job that you talked about is harder. But at the same time, they're also keen to stop studying the Earth from space. Although you were looking at the Space Telescope, or at the Hubble Space Telescope, there are many NASA satellites that, in fact, NASA is one of the prime places to look down on Earth. And I wonder if you could just talk about the challenge of studying the Earth, so we can, as part of what was talked about, in order to be able to deal with the Anthropocene, we have to know what's happening. And to know what's happening, we generally have to look from space. So I thought you might want to.
And that's really the important point. We can try and measure the temperature of the surface of the Earth and CO2 at a few sites around the Earth, and then make some, guess about what happens everywhere else. But if, most of the Earth is covered by oceans, well, we can put a few buoys out. And if you do that, there's very large uncertainties in what's really going on planet Earth. And so fortunately, those little streaks that David Grinfood talked about, those rockets launching, a lot of those are Earth observation satellites. And some of them are satellites that are used to observe the Earth for our daily weather forecast. And that's very practical use. But over time, they're also very useful to look for these other changes. And NASA specifically launches satellites to look at aerosols in the atmosphere, to measure the sea surface height, to measure the ice height and thickness, to measure CO2 content. And that gives you, a view of the whole Earth, maybe not the pinpoint detail, but it allows you to actually measure the properties of the Earth as a system, which is extremely important, so that we can take our climate models and run them to see if we actually understand how the Earth does work. And that has two good functions. One of which is, if you want our senior decision makers, say the President of the United States, to make wise decisions, he has to have good data. He or she. In this case, he.
Yeah.
And
In this case, it. But anyway, go on. Okay, sorry. Sorry, go on. I couldn't resist.
And without that good data, you don't make good decisions. Now, that assumes that we have a rational decision-making process that's data-driven. So it's very important that we get that data. And the challenge is, you can't take the data for 5 years and then say, okay, we've got the data, we'll go off and write a bunch of scientific papers and let the satellite spiral into the atmosphere. You need data records that are not only decades long, but eventually we're going to need century-long data records that are, we've only had space program for 50 years. So it's critical that we have those measurements. Now, the good news is that even the biggest climate change skeptics, human-induced climate change skeptics in the Congress, all agree that they want the data. They just don't want scientists telling them what to do about it.
Okay, but well, actually, let me put on keep this hat on, but put on my optimistic hat for a moment, or at least your optimistic hat, because I was bemoaning the fact that in the budget that's been proposed, there's a lot of talk about cutting the NASA Earth monitoring satellites, and you point out to me that many of them are already existing and don't cost anything, and probably therefore won't be cut. So maybe you can make people feel better for a moment if you just talk about that for a second.
Yeah, well, first of all, the good news is that a number of different federal agencies study the Earth. and there's some obvious ones. Department of Interior, U.S. Department of Agriculture, for obvious reasons. Agriculture, that's our food source, so that's important. And in order to have a steady food source, they have to understand crop health and other things, which the U.S. Geological Survey operates the Landsat satellites, which tell us about land use, but also crop health. And they also, as sort of an ancillary benefit, because we've had this long-term record from the 1970s, tell us about climate. So those things are unaffected. NASA operates research satellites for scientists, like those at the School of Earth and Space Exploration, to try and understand the basic processes and write scientific papers. We typically design those satellites for a 5-year lifetime, but NASA overachieves, and they typically last for decades. And so we get these long records. The budget for NASA Earth science research is around about $2 billion a year. And this new administration, lots of bluster, lots of critique about climate change, has adjusted that infinitesimally, such that the bulk of all the research will continue and the satellites will continue to operate. And even if you turn the budget off, the satellites don't fall out of the sky, which is good news.
Okay, good. Well, that's okay. Now, moving from your optimism, let's talk to David, who seems to be an incredible optimist. And I just want to try and challenge you on some of that optimism, at least I mean, it's nice to realize that we can do good as well as bad, and I think that's really important. But especially in terms of what Jane sort of emphasized and I introduced as well, the example of ozone is not really a good example, right? Because you can solve that problem, and carbon dioxide is a problem. It's even actually, I think you were a little too optimistic in that sense, because it's not just that you can ignore the problem, but it gets worse in a much worse way. The need, if we don't act till 2030, we have to remove twice as much. The technical demands on what we need to do are much greater than now. So it's not as if we can say we don't have the money now, we'll wait till later, because later it's a lot worse. So I wonder if you might want to sort of contrast the ozone case to carbon dioxide.
Yeah. First of all, I think this optimism versus pessimism dichotomy is not really necessarily that useful, or is maybe an oversimplification. People sometimes accuse me of being an optimist because I have a vision of that I try to talk about, of the role that the human race could aspire to play in the future. And at the same time, I think that we face huge problems, that we're in a serious crisis that I think Jane did a very good job summarizing in the first part of her talk. I think that we can have both those ideas in our heads. In fact, one definition of a mature mind is that you can hold seemingly contradictory ideas in your head at the same time. And it's not enough to think of what we want to avoid on the short term. We have to think about that, but I think it can help us to think about that if we are armed with a vision of what kind of a role we want to play on the planet and what kind of world we want to create. And there are some encouraging signs. I mean, it's clear that it seems clear that world population is going to peak and then start to decline later this century, for the right reasons, not because death rate increases, but because fertility is decreasing, because poverty is decreasing, and the choices of women are increasing when women get more educated in poor countries. These things are happening. We've already passed peak birth rate. And it's also very clear, 100 years from now, we're not going to be on fossil fuels, even if we are as stupid can be. There's a point where you move beyond that. Now, so there's a best case and a worst case scenario for how we're going to get from here to there. And being human beings, it's not going to be either. I mean, humans can learn from foresight and being smart and avoiding stuff because you can see what's coming, and we learn from tragedy. And we do both, and it's going to be some combination. It's going to be something in between best case and worst case scenario. So there's going to be some damage in the 21st century. I have no doubt about that. The way I look at it, if we do this wrong, the 21st century could be as tragic as the 20th century. And when I say that, people say, what are you talking about? The 20th century was great, you know, woohoo. Except it wasn't for the hundreds of millions of people who died in wars and famines. I think that's the scale of tragedy we're facing. So that's so I'm an optimist in that I see that we can get through this and move on to another phase. And I think we have to picture what that is and think of ourselves as a geological force, which means thinking on the long term, thinking about asteroids and ice ages, as well as our immediate challenges. Now, specifically, just you asked about ozone. I agree. Ozone's a much simpler, much easier problem. You know, it basically was a couple companies that had to phase out their products and phase in new ones, as opposed to fossil fuels, which our entire world economy is based on practically, and it's huge amounts of money and resources and infrastructure. So that's a much harder problem. So I use it as proof of concept. But it's sort of idealized, and it doesn't mean, oh, this is going to be easy. It means we have models that we can try to apply.
Okay, actually, I think you're overly pessimistic about one thing. To go to your defense, my friend Steve Pinker has argued, I think pretty cogently, that the 20th century was perhaps the most peaceful century with the least death and the least violence of any century. And while we tend to think of the wars as having done a lot, actually, the general human attitude about murder and death has actually gotten better over time, largely, he would argue, because of the Enlightenment and science. But I will.
I don't disagree with that at all.
I was amused by the talk by your person of the fact that the two times that at least two times we've dramatically changed the climate, which is cyanobacteria and humans responding to climate change. In both those cases, the oxygen that's produced killed most of the. So they changed the climate by dying. And the same thing happened with hominid species. Probably when there was climate change, one of the reasons Neanderthals probably were destroyed by Homo sapiens was climate change. So there's a long history of species changing the planet and not surviving in the process. And I'm wondering whether you might want to comment on that.
Well, this is absolutely true, but it's also true there's a long history of humans and pre-humans interacting with climate and learning and growing and becoming, in a sense, successively more successful and more human, in a sense, in the process. If you look at all the major innovations that led us to be modern human, we're discovering things like upright walking, larger brain size, domestication of fire, various kinds of social and material technologies. Almost all the big breakthroughs came during times of climate chaos and in response to climate chaos. And there's a paleoanthropologist here at ASU named Curtis Marion, who's worked in this site called Pinnacle Point, very near the southern tip of Africa, which is where some people think, Curtis Marion thinks, and I think he may be right, is the origin of modern humans. And that was the humans that were driven there, they retreated there in response to an ice age about 190,000 years ago. And most of what was going to become the human race was wiped out. There's a genetic bottleneck. In fact, we might have been down to fewer than 1,000 individuals. 500 or so. Yeah, a few hundreds of individuals, which is, by the way, partly why the human race is so incredibly uniform genetically compared to other large mammals, where really all humans are the same genetically, because we survived this bottleneck and re-radiated. But the humans or human ancestors at Pinnacle Point had to reinvent themselves and reinvent what it meant to be a cooperative, innovative species on the planet. They could no longer be hunter-gatherers in the way they had been, because Africa was covered with ice and the range wasn't there, the game died out. And so they invented what is known as complex long-chain recipe technology, where what you start off with is not obviously related to what the products are. So in things like heat treatment of rocks underneath the ground to make hardened rocks for new kinds of tools and spears and things. And in order to do that, you needed language, because you needed to be able to communicate it to the next generation. This is also the first site where we find ochre and adornment, and a lot of the things that we think, oh, this is where modern humans might have formed. And they formed in response to a climate crisis. They reinvented themselves. They became better at the things that we humans have distinguished ourselves by, which are cooperating, inventing, communicating, enlarging our sphere of cooperation. And we've done this many times in the past, and I see, in a certain sense, this is encouraging. It shows that, in a sense, we have the capacity for reinvention. And I'll say one more optimistic thing, which is, imagine trying to describe a modern city to the people from Pinnacle Point, say 100,000 years ago, how we live now. You wouldn't be able to do it. Now, maybe that's as hard as it is for us to imagine the fully sustainable society that we will have a few thousand years from now.
Well, I certainly hope it's the case. It is an interesting point that severe climate change, but from an evolutionary perspective, has often brought new opportunities. I would argue usually by new species, and from my point of view, I'll throw this out, that maybe the new silicon-based life forms that we're creating now will be the next species that will survive and maybe be better planetary managers than we will, but we'll see. But,
well, I think that's really the salient point,
yeah,
is the loss of biodiversity. That's how deep a hole we might be in.
Yeah.
Or maybe some kind of partnership between us and them.
Well, I think that the issues, David, or the things that you've been describing, David, I think are all what I would call emergent. They're all actions of individuals or small groups of individuals that add up to something, a new pattern. And the question is that the kind of problem that we're facing right now? Because if we need some kind of coherent action to change things, then I don't think there are too many examples. Maybe D-Day or something, but even that you could go after. I think that the issue is that we don't know how, as a species, to set goals for the species.
Certainly,
we
we've never
really don't.
We've never had to do it globally.
We've never had to do it.
This is the first time, and there's no. Looking out at the world today, it's not. One would not be optimistic that we're doing a good job of thinking globally yet. And I want to get you.
There are some examples, though, from the realm of public health. There are diseases that have been eliminated globally. We're obviously not as good at it as we need to be, but it's not true that there are zero examples where we've been able to get together and solve problems globally.
Yeah, well, okay, good. I'm not. One could argue that, but I think I'd like. As I often say, from my friend Cormac McCarthy would say, when I asked him why he was so cheerful, he said, "I'm a pessimist, but that's no reason to be gloomy." So that's my attitude. So let me, however, try and confront you about one thing. So there's the two interesting geoengineering things you talked about were putting these aerosols or something, dust or whatever you want in the atmosphere to block sunlight or potentially block sunlight, or extracting CO2. And you said, well, we may need to just keep doing the first until we get the second straight. I have a problem with the first, and that is that
only one.
Lots of problems, but you point out that the first, what happens. The second, what happens. You take CO2 out. We know what it was like back then, so we know what the results will be. But putting things in the atmosphere, as you point out, has a lot of unintended consequences. But for me, the worst one is that if we chose in the United States to remove CO2, we make a unilateral decision, and it improves the world. Okay, but someone's got to decide to put those aerosols in. And there isn't going to be global consensus necessarily that they're willing to take the risk. But one country does it, and the whole world either suffers or not. And who has the right to do that? So I wanted you to comment on that.
Well, this is, of course, the biggest problem with all of this is that somebody's got their hand on the thermostat with this concept. Personally, I don't think it's going to happen that way anyway. I think things like what Hilary is describing are what's going to happen. I think what's going to happen is that people are going to start to feel impacts, and they're going to start to want to do something on a much more regional basis, and that the impacts that they feel are going to get bigger and more widespread and last longer, and the kinds of interventions that they choose to do are going to get bigger and more widespread, and people are going to think of more things, and they're going to start to affect the globe. again. And then I think what you're going to see is, I think that it could be emergent at that level, that basically people say, I can't stand this heat wave, it's been 130 for a month, we got to do something, and they're going to start to do something locally, or they don't have the monsoon, so they're going to overturn portions of the ocean and try to steer rain differently. So these things people will think of more of these things. Now, the question is, will they work? I mean, this is the other piece of it. Why do people keep coming back to this SRM idea, solar radiation management idea? Because we know it works. And that is really pretty amazing. And also, don't
we
get...
know it works at some level. It also often kills crops and people. I mean, if you look at what happened to volcanoes, there was a lot of starvation as a result of that because of unexpected climate changes that were resulting in...
Yeah, so the question is, do you get smart enough to do it right? And I'd say, I don't know. I think, but we damn well better do research, because even if you don't think you should do it, somebody else may do it.
Yeah, well, that's what, that's why I want to add, the second question I want to ask you, and then I'll move to Hilary in a sec, was I'm worried because I actually I remember on a radio program with a scientist who was strongly advocating this, and there are scientists who are strongly advocating this, and it seems like a quick fix, a quick and easy fix, which means you don't have to think, you don't have to change the way society works, you don't have to do the hard problems. And what worries me is that appeals tremendously to politicians, especially certain politicians.
You're right, that's a huge problem because it's just not true. That's why it's a problem. It's just fundamentally not true. If you don't mitigate, if you don't stop emitting, then the gap between what you're trying to do radiation balance management with grows. And it grows, and you get farther and farther and farther away from any known state of climate that we've ever been in. So the fundamental strategy is first and foremost mitigation. You have to stop emitting. And I just have to get in my one other dig. I really get upset when I hear people say, just leave it in the ground or we won't be using fossil fuel. Because what that does is it leaves out a whole raft of solutions that actually do involve fossil energy but don't emit. And we have to be open to all of these things. We have to be open to nuclear power. We have to be open to carbon capture and storage. We have to be open to some amount of renewable energy. But we have to be doing all of it. And just to say we're not going to use fossil fuel anymore is, I think, cutting off one of your arms in terms of getting forward on this.
So do you, and this will lead me into Hilary, I think, nicely, but do you think we, as scientists, is it, at this point, should one so what worries me is advocating a potential solution or advocating research to look into the possible effects of that solution. But is it irresponsible to say, to argue strongly for solar management instead of arguing for mitigation and research into possible ways?
That's unethical, I think.
Yeah,
So
okay.
I think that's unethical.
Oh, okay, I would agree, but I wanted to see what. Well, and then that leads me to Hilary, who talked about two things that I want to try and confront you with, or at least one. Well, two. One, you talked about PlanetWorks, and I wanted to say one of the reasons I'm so happy to be doing this with PlanetWorks is that bemoaning the problems is one thing, but thinking about how to solve them is really much more productive, and that's what we're trying to do in a number of things in programs we're working on. And I hope that the lesson is that we need to think about these things, that there are huge challenges, but fortune favors the prepared mind, and we need to prepare. But you said advocacy, and I'm wondering, so for example, my friend Jim Hansen is an advocate. A lot of scientists wonder whether he's too much of an advocate. And should we be advocating specific policies, or as scientists should we be pointing out the science and encouraging the people who are elected to determine policies? I'm wondering what.
You raise an excellent point, Lawrence. And advocacy is a pretty fraught term right now. And there's no question that as scientists, a lot of our credibility comes from the fact that we produce information and we are willing to say this is the best information that we know how to make. But I do think as we move into the Anthropocene that scientists are also responsible for interpreting their information and providing a way to read the information that we generate as scientists for the public.
Yeah.
And if that's advocacy, then I'm good with that. Maybe we need a new term for it. But I do think we have a responsibility as scientists to also interpret our information in the best possible way we can. The idea of generating data, producing information, and then leaving it at the hands of a regulator or a politician who doesn't have the tools to interpret it, I think that's also unethical.
And my wife used to work for the government in Australia and pointed out that scientists and government officials don't. The scientists think they know what the important things are, and they're very different questions than what the government officials do, and they need to be able to communicate and learn how to communicate to each other.
That's a critically important point, right? And I could have talked for a long time.
Yeah.
It's really important to remember that PlanetWorks is not just the scientists and the engineers. We are absolutely involving social scientists and people who study politics and law and ethics and humanists as well. That conversation, all of what we're talking about is really about how do humans make decisions and which decisions do they make and why. And science isn't going to answer those questions. Those are the questions that we need the human endeavor to answer those questions.
Okay, let me give you another sort of devil's advocate, last devil's advocate question, and then we'll move for about 15 minutes of public questions, if there are them. I couldn't help, when you were talking, thinking of a line from the Rocky Horror Picture Show, which was, treating the symptoms and not the disease. And so do you think there's a problem? Let's say, this is a neat way to make more ice. We don't have to worry about, that providing these things provides an impetus, or could provide an impetus to see business as usual. Look, we got the technical solutions. We don't have to change the way we live.
Sure, one could say that, but it's exactly the same thing that Jane's saying about sulfate aerosols.
Exactly.
We have to do everything we possibly can right now. And if that means buying ourselves some time, then we should buy ourselves some time. But we have to recognize that the CO2 problem gets worse. The CO2 problem is currently accelerating. Mm-hmm. And we can moderate temperature all we want, however we decide to do it. But the CO2 problem is growing underneath that. And so we have to make that point.
In that regard, I was going to ask in your paper, because I haven't read it, is presumably, obviously, in this kind of sea ice thing, it's a lot easier to impact on the problem now than it will be in 20 years if business as usual, because then, to recreate all the Arctic sea ice is a little bit different than increasing it by a meter or something.
Oh, that's absolutely right. In fact, I'm pretty sure that you can't recreate sea ice. You can only thicken existing sea ice because it won't freeze at the seawater temperature.
So in 2030, this problem will be too late to.
Oh yeah.
So okay. Well, do you want to say something?
Yeah, just I want to maybe address this issue. I think one of the things that we really need to start doing.
1 second. While you're talking, it looks like people are jumping, but go ahead. Feel free to go to the microphones and get ready if you have some questions.
E.O. Wilson is one of my heroes in his book Consilience. I think we are still training people to be reductionist, and part of the science needs to be the system science.
Absolutely.
And because we need to be putting these things in context for people. And second thing I want to say is I think we need a new career path for people that are neither scientists nor humanists, that they're somewhere in the middle and they're translating. They're moving forward, trying to understand what the meaning is and communicate that.
Anthropocene studies.
Yeah. Well, it would be great to have it would be wonderful to have scientifically literate humanists and humanistically literate scientists. Anyway, so on that optimistic.
You're not optimistic.
No, I am. I think it's a goal, and I think it was actually we've moved away from that. It used to be, as an educated person at the beginning of the 19th century, if you didn't have some basic understanding of science, you were considered not educated, and that has changed. But let's go to the question. So
my name is Moti Gudipati from JPL. Mm-hmm. I have a comment and a question.
Okay, the comment will be short, I hope.
Yeah, comment is that we tell that the humans are putting Earth in danger, but actually we are not putting Earth in danger, but we are putting our own selves in danger. So that is the key point that we need to give it to the common public, that their children and grandchildren and grandchildren, or the humanity is in danger, not Earth, because Earth will exist without us. Okay, that is a comment. We have to change that paradigm and then focus on humanity rather than Earth.
Okay.
Earth will be there as long as the sun is there. So the question is, energy is pollution, and energy is addiction. And as Ed Taylor, what Ed Weiler said, no, not Ed Weiler, sorry, Ted, someone.
Someone said.
Someone
doesn't really
said,
matter. Okay.
someone said, energy consumption is equivalent to prosperity. Now we have, as you all said, 9 billion people here. It will be rising to 15 billion sometime. How do we reconcile the energy consumption to the human population, and how do we tell them, starting from the second that you go to sleep to the next 24 hours, how you consume energy is going to actually dictate how humanity is going to be in the future.
Okay. Well, I'll turn it to, I have my own ideas, but anyone want to address that question? You want to start? Why don't you start, Hilary?
I think your point is well taken, but I think one thing to think about is that when we talk about energy consumption, we are talking about mid to late 20th century energy consumption rates that haven't changed. I think there's an awful lot of ingenuity that can change, it's really efficiencies, that can change the way energy gets used in the future. But your point is well taken about population.
I will say that part of the effort to think about managing the planet is related to the fact that much of consumption, not just for energy, but water and all of the fundamental things that humans use to live, has been done in a world where it seemed limitless. You could be incredibly inefficient and incredibly use far more than you need in many things. And so there are a lot of there's a lot of low-hanging fruit that comes from just simply increasing efficiency, because things have been so inefficient because it hasn't been a problem. It's been cheap, energy's cheap. In the first world, water was plentiful, and so why not use it all and do so many things? Why not overcool buildings in major cities so that you have to or overheat them with lights so that you have to cool them unduly in the summertime instead of not overheating them with lights? Lots of things like that I think can be done very effectively to reduce the net consumption even in the first world.
You know, there's one other aspect that I think should be mentioned that we haven't really mentioned yet this evening that Murty's question makes me want to bring up, which is that we talk about we human beings are doing this, we human beings are doing that, we have to limit our energy use, but we also have to remember there are issues of global equity, and there are rich countries and poor countries, and we Americans have used up more than our share of energy, and yeah, we have to learn to radically curtail and transform our energy use, but there's also a lot of people in poor, underdeveloped countries that are going to, in this next century, have the desire and the right to increase their energy use, to bring up their standard of living. And so it will be really smart for us, thinking of the global situation, to help them do it in a way that is less globally destructive. And so alternative energy for poor countries, letting them use more energy as is their right, helping them, but helping with the technology and everything that goes with that technology so that they can do it in a way that is compatible with a better future for all of us is going to be really important.
Okay, next question.
How do you deal with the...
Oh, okay, there, yeah. Didn't
How
see
do
over
you
there.
deal with the issue of the good side of global warming? I can think of people who might think it's a good idea to have a warmer Siberia, an Arctic Ocean that's open to shipping and development, and a warm water port for Russia. So how do you... There must be some people that want more global warming, and how do you counter them?
There are a number. One who may become the president's science advisor, in fact, who strongly believes that plants need more carbon dioxide. So you know, I think, well, again, my feeling, I'll start it, but I'd be happy to hear what other panelists say, is that one has to talk about all of the implications, and it's really important to have an informed discussion, and point out the many Anyone, maybe if you're, especially someone else's microphone. If you didn't hear me, I wasn't saying anything important. It
Well,
doesn't
of
really
course,
matter.
that's the problem. That's only one part of the problem, right? If you are going to manage the globe and do it in a top-down way, and then if you think you're going to do it in a democratic way, you know, I think we're getting a real civic lesson in what democracy can bring us in this country today. So I think the issue is that we don't, as a people, we don't know how to do that, and yet we're facing problems that have that magnitude, that probably require some kind of top-down or some kind of global decision. You know, I mean, how many people in the room have taken some action to reduce their carbon footprint? Everybody, right? And so what's the net impact of each of your actions? Practically nothing. And yet, if we could do something on a global level, it would maybe have an impact, but we can't make decisions like you just did to do that. So I think we're probably looking at things that have to do, again, with more regional solutions where people can make decisions and they do have some impact, and those things growing in some way. And I think that's probably what's going to happen.
I will say that, you know, Einstein said after the first nuclear weapon was dropped that everything's changed save the way we think. And we still think the same way, even then.
Yeah.
There's a clear example of a global threat that we haven't addressed at
Yeah,
all.
yeah.
Let me just say that, you know, the way I distill that question that you asked is not about, you know, ports or better agriculture, which is specious anyway. It's really the question, what's good for me or what's good for us?
Yeah. And
And
I
if you
think,
ask what's good for us, it's a very different dialogue. And then you have to get to the systems question of, you know, looking at the Earth as a system.
and you have to think of us, as David was pointing out, this is a real concern to me, especially in this country now where policy is being driven by me instead of us on just a national level. The us that we should be thinking about is not us in the United States or us. The us should be global, and that's never happened, but it needs to happen, I think.
And I'll just add, I said it before, but it's not just us human beings.
Yeah.
You know, it's about global biodiversity, because a world without bats, without bees, you know, is a world without fruit. And that's going to be an icky world. I like fruit.
Yeah, and the oceans probably have already begun to be impacted more than any other area, and so we're dramatically affecting life in the oceans already.
So from a certain perspective, on a certain shorter time scale, there would be regional winners and losers. But from a larger and longer term perspective, there are not going to be any winners if we push our global systems beyond safe boundaries.
Okay, we'll try to take some more questions and we'll try to be briefer, but we'll go a little long, I think, if there, as long as there are audience questions. Yeah.
First, I've had some home maintenance and repair issues this week. I was just wondering, Dr. Grunsfeld, that third time you went up to repair the Hubble, was that thing still under warranty?
The warranty ran out actually 5 years afterwards, but I will still service it.
All right. Well, I think,
Actually, the good news is that, you know, we thought it would last about 5 more years after the mission, and everything's going great. And so that and a very calm solar cycle, which is actually important for the Earth too. Hubble should continue operating another 5 or so years before the next thing that we can anticipate will happen to it.
Let me, in that regard, so the James Webb Space Telescope is going up next year.
October 2018.
And so they'll run in tandem.
I'm
And
very
there's a
excited
budget,
about
and
that.
there's budget funds to keep the Hubble going for
Well,
another 5 years.
Who knows?
I mean,
That's a big question.
because people may say we have the James Webb, so turn off the Hubble.
But scientifically, it's very exciting to have both.
Okay, thank you. I think I'm going to only allow you to ask one, just because we have so many. Next.
Thanks. Yeah, I wanted to say a quick hi to my daughter, Marissa, who's in Oregon watching the stream and told me about this. But I felt like maybe you were flirting with this a little bit. Is it crazy to think that if we don't find ways to protect, you know, our fragile planet, that the planet will figure out ways to handle it for us, like you know, pandemics, things like that? I mean, do you worry about that a lot?
Anyone? I'm not going to touch that one. You want to?
I do worry about that.
I mean, it's certainly true that we are being challenged. One thing we didn't say is there are problems. You know, biologically, we may be able to survive climate, the worst parts of climate change, but what is really important, and it's relevant to, I think, what Hilary said, is there are incredible socio-political impacts that are going to produce tensions and wars and for scarce resources, not just water, but other things, energy and space, land, and food. And so that I personally think the greatest danger to humanity is the socio-political implications, the tensions, the international tensions that will result from these things, which could lead to devastation via global wars. I think that's in my own mind, a bigger problem.
This question is mostly directed to Jane, but I'd like to hear all your views on it. What do you think of the carbon sequestration technique of locking the CO2 up in carbonate? It's obviously still a Band-Aid solution because eventually we'll run out of space to put all the carbonate, but as far as Band-Aids go, what do you think of it? And if you don't like it, what's your favorite sequestration technique?
I don't think like is kind of the way. I don't like it. I think it's just slow. You know, I think these carbonate is a great way to go, and also can serve as a buffer in the ocean. And I think those are really great technologies. And some of them are even downhill reactions. You would be able to react more than I react. Sorry, you'd be able to discuss that more than I would. But the fact is that they're either mass limited or rate limited. You know, you just can't get things moving fast enough, either because you can't get enough mass involved in the reaction, or the reaction is too slow. And I think that's where I have a lot of doubt about whether any of the carbon sequestration technologies that we're talking about now will pan out in the long term as being meaningful and scale-wise. So that's why people are starting to talk about air capture, actually filtering out of the air. And then you still have a problem, because although people think that, like you said before, well, this is just natural, we're just going back, you're actually not going back, because you still have to put the CO2 someplace. And so I personally think what we'll be doing is taking it out of the air and putting it into the deep ocean, sacrificing the deep ocean. That's what I think will happen in the long term.
Okay, well, we'll proceed. I want to try and get through as many questions as we can. Yes?
Okay. Everybody's heard about Venus having 20 or 200,000 times as much CO2 as the Earth and being warm enough to melt lead. Nobody talks about Mars having 20 times the CO2 as the Earth and can't melt ice. Anyhow, in The Climate Near the Ground by Rudolf Geiger, translated from the German in 1951, he points out how nonsensical the CO2 greenhouse gas theory is, because water vapor is like 6 to 20 times the greenhouse gas as CO2. And also nobody talks about biosphere.
Well, okay, so do you have a question? I mean,
Yes.
First of all, a lot of people do talk about all of these things. Let me
Okay.
point out, the climate scientists actually spend their lives worrying about just these questions. Let me
Okay,
make
but-
that clear. It's
okay.
not some secret.
No, but
Okay.
Biosphere 2 was supposed to show sustainability, and they had to bail out because of low oxygen after a short period of time, because they're generating CO2 at 100 times the rate of the as the Earth is doing it.
Okay, once again, so you made a statement. I don't want to.
So just to correct one thing, the atmosphere of Mars perfectly validates our ideas about CO2. It's a very, very thin atmosphere, and the fact that Venus and Mars have surface temperatures which our climate models predict very, very well with our basic understanding of the absorption of CO2 and other gases actually validates our understanding of the way climate works now on Earth and will work in the future. This is what I actually do for a living, is models of these other atmospheres, and it works rather well, and it's one way that we know that our physics of how radiation interacts with atmospheric gases is basically correct.
Okay, next question.
Hi, Jacob Buckminster, Blue Marble Space. James Lovelock, the originator of the Gaia hypothesis, has recently articulated that we don't need sustainable development, what we need is sustainable retreat. And what this says to me, it's sort of the ends between hubris and humility. On the hubris side, we have a strong belief in human technology, geoengineering or other things, to be able to overcome these environmental problems. And on the humility side, it's maybe there are a lot of uncertainties and maybe we need to step back and maybe we need to think about reducing our lifestyle in the United States, not necessarily bringing everyone else up to our standard, but maybe we need to sacrifice. So what are your thoughts on that?
I think you're absolutely right. It's both. We need restraint and innovation, and there are people that believe in only one and not the other, and they're both wrong.
And I think the point though that Jane was making, and I think what President Obama used to say, which is true, which is that restraint doesn't mean a worse quality of life. You can find better ways to create new technologies that allow you to live better with less. And so it isn't always just a matter of doing without. It's a matter of finding ways to do with less and do more with less often. I think that's really an important thing. And technology is the key.
Well, I think you could get down another layer in some of this that we haven't done. There's bang for the buck on efficiency. For example, we have no real replacement for gasoline in mobile transportation for the most part. I mean, biofuel might become carbon neutral. It's not now. And it's going to be limited by biomass. So this is where efficiency and conservation really make a huge difference because we don't have a technology to replace it. Could we theoretically decarbonize electricity? Yes, we can. We know how to do it. So their uses of electricity might expand, and if we can still create enough electricity without carbon dioxide, we'll be fine. It doesn't matter. But if you don't have the technology, then efficiency becomes important. And I don't think we've thought that way.
Yeah.
You know, we haven't parsed the problem like that enough.
I have one other thing to add to this idea, and I think it's important to remember, at the risk of sounding like a chemist, time and human evolution is a one-way reaction. We don't get to go backwards. We can make the forward reaction different, but we can't turn it around and put the genie back in the bottle on this. And so we have to look forwards and not think about it as retreat.
Excellent. Okay.
Hi
Take
there.
a few more. Yep. I'd like to end by 9, which is about 15 minutes longer than I planned, just so you know if you're here.
All right,
Yes.
I'll make it quick. So I'm now more aware than ever of the current unsustainable trajectory of our society. And through that, I sort of feel like a responsibility to do something about it. Because if I'm going to be doing work on this planet, I'd like to help make the planet work. So I'm just curious, how do I sign up for this program and become a steward?
In the near term, send me an email.
All right. That's my only question.
But actually,
Yeah, there we go.
But let me say, as an individual, I mean, I'll talk about some of the things that I've done. I mean, there are a lot of individual choices you can make, and alone, your choices are not going to have a big impact on the planet. It's only when we act collectively. But really, at all levels, about decisions you make every day, about decisions that our elected officials make, about decisions the UN tries to make collectively, that other nations make, it's those decisions that make a difference. So when you, let's say you decide to go buy a car, you go into the dealer, and at about the same price, you can get an F-250 double wide, or you can buy an electric car. And you get to make a choice. And the good thing is to try and educate yourself and make a wise decision with whatever criteria you have. If you want to haul manure, you're probably going to get the truck. If you want to try and get basic transportation and have the least impact on the planet, get the electric car. When you eat, there's a huge energy difference between eating vegetables, chicken, and beef, for instance. And so you can decide how often you eat what of which and where it comes from that has a large energy difference. Now, it's going to make you feel better that you're helping the earth, and if you make educated decisions and then also influence your friends and neighbors and maybe become an elected official, you can have more and ever increasing influence.
I
think one thing I think is really important that people don't talk about too much, or people are beginning to talk about, is avoiding groupthink. I think one of the things that people are beginning to show is that that people tend to believe information from people they think are part of their tribe or their group. And I think what we're doing is propagating a lot of information on all sides of this problem that are not, that isn't really true. You know, what was the big pipeline? The Keystone Pipeline, you know, was going to be game over, and everybody glommed on to get Keystone Pipeline. Keystone Pipeline, a year of emissions from Keystone Pipeline associated with that is 10 minutes of carbon dioxide from China's coal-fired plants. You've got to be able to put things in the right context and understand that. And so I think we have, as a society, as an individual, you have an obligation to go beyond what everybody's telling you and figure it out. Figure out what the right way to think about this is.
But as scientists, I think, as Hilary was saying, I think that maybe it's not advocacy, but what we need to do is translate in an effective way so the public can figure things out, so they do have access to information that's understandable and clear. I mean, here's one example. It takes 3 tons of water to produce the feed for a cow that produces 1 hamburger, for example. It's the kind of information that is digestible, literally, if not metaphorically. But I didn't plan that. That just came out. I know. But no, the point is so that I think the real thing that if the public's going to be able to act, they have to have access to information, and not just raw information, but information that is comprehensible, clear, and complete, and then we can expect people to act responsibly.
Another thing I would say is don't give up. Don't assume we're on an unsustainable path. History is very nonlinear, and the future will be too. I recently did a project where I spent a lot of time reading predictions of the future written a couple hundred years ago about now, and all these smart people nobody gets it right. And I'm very confident that none of us can really predict the world of 100 or 200 years from now. Not climate models, not modelers, not economists, because there are game changers. Not just technical breakthroughs, but human beings also go through nonlinearities and phase changes in the way we think. And history shows this as well. So make your, it's about your personal choices of the kind that John mentioned. It's about communicating with your representatives. Because at some level they still do represent us, and they listen, they succumb. And, but also communicate with your fellow humans, education, communicating with our representatives, and personal choices. And it does add up and make a real difference.
Yeah, I think we're going to, go ahead.
Imagine one of those, big nonlinearities that we can't predict, where we have a Congress that works together and actually gets...
No, that's right. I think that's true science fiction.
I would put it, just one thing, I would put it in these terms. I was serious, send me an email and we can talk more. But have the conversation. And the conversation's not always all that easy, but find some piece of the conversation that you can align with someone on and talk about it. We've gotten bad at having these conversations because they're conversations about values. What do we care about? And those conversations are challenging, but they're very much a part of how we're going to change this.
Exactly, we need to do that and not trust anyone who calls themselves a futurist too. Now the person who's at the microphone is going to really hate me right now, because what I'm going to say to you is I want to ask that woman in the back to be able to ask questions. We haven't had a single question from a woman, and there's only one woman here in the line. So if you'd ask the question, it'll be the last question.
Oh my goodness, thank you.
Okay.
I just want to say this is kind of a follow-up to what the young man was just talking about. I think what's really encouraging, because I'm an eternal optimist, my background is in political science and environmental planning, and that I think what we need is leadership. And I think what happened with the Science March this last weekend shows that a lot of the public are ready to support scientists and to marry and somehow on many issues and move forward. And so I just want to encourage everybody here to kind of engage in that manner. I'm sure there are many people that were at least interested, if not were there. And so I would ask, I guess, again, with the Planet Works, that you're trying to kind of have a prototype and maybe take it to other states and other universities. I think that the greatest thing that we can do, even though we're not scientists, is to back you up, because you have some of the knowledge and we can maybe help explore other avenues as well. So I want to thank you all for your voices and the dialogue. That's what we need. So
well, thank you for that.
Thank you.
And I think yeah, that is That was a great way to, that was a great last question, and even though it was not a question, it was a great way to put this in perspective. And we have to thank you for supporting it. But I will say one of the reasons that Planet Works is interested in managing things, and that we at Origins are interested in this is being broadcast around the world right now on the internet, and it will be recorded and online. And the purpose of this is to provide the information so that you and the public can then act on it. Because the leadership we can, as scientists, can provide is really providing you the information. The public has to take the lead in all of this, and we'll never do it alone. And so that's why we do what we do, and I want to thank all of you for supporting it. Thank you very much. For being so good. Thank you.